Alright, just to make sure everybody's on the same page, I'm going to go to Google and I'm going to type in NCBI and nucleotide. That's where we need to go and get our sequences. Now we're going to get the same ones we've really already gotten before, maybe a couple of new ones, but in general we want GPX1 and Homo sapiens, so GPX1, and you can type out Homo sapiens. You might be able to get it with just human, but I will say Homo sapiens, and we will search. Alright, and here we go. This is the correct one. Now the first one we want is our standard, the one that's 8,000 base pair. So if we look through these and we kind of scroll down a little, you should find one that's really large somewhere. Here it is, 8,183. That's the one we want. So if you don't have this one, you should. We need to get this one, so I'm going to download that. Alright, and save file, and well, I'll go ahead and click on this one and we will create that file. Alright, I'm going to save it. Okay, now understand that this one is actually RNA. This is not a DNA sequence, but we want to use it kind of like a DNA sequence. So if you want to understand the issues with that, I put out a video recently that kind of explains what to do. Just find the complement for the sequences you're looking for, and that'll find the equivalent in DNA. So if you're looking for a TATA, instead of looking for TATA, you would look for ATAT. That's the only difference when searching for sequences. And you guys are going to be looking for a GC box in this sequence. So instead of GGG-CGG, you would look for CCC-GCC. But yeah, they really mislabeled that. This one is on chromosome 3. They made so many mistakes. There's no way of knowing this unless you do what we're about to do now, which is what will tell you that, oh wait, this is not DNA, this is RNA. And of course, let me show you what's going on here. This is just the first sequence we want. Let me go back here and let's grab another sequence. Let's go to Refseq Proteins. So what I'm going to do is I'm going to go Refseq Proteins, and realize this says isoform 1, 2, 5. Well, these are the results of splicing, so these proteins are different. So let's go get the largest one of these proteins. Let's go get this one, 170, and this is isoform 4. Yes, isoform 4, which is, no, is that one larger? No, isoform 1 is the largest, 203. So let's download this protein. Alright, so I'm going to go download it as a FASTA. Now this is the first time we've done proteins. And of course, here we go. This is the protein. Notice how much smaller it is. So we're going to go, let's see, file. Alright, FASTA, we can include the GI, and we're going to create file. Alright, save. Your system, of course, may do it a little different than mine. Now I'm going to go up here and I'm going to look at these. So I'm going to go in this folder, and here we have our 2 FASTA files that I want. So I'm going to cut those, and I'm going to put them on my desktop. Let's see. Oh, can't do it. Got to do it down here. All right. And now let's go and grab those. Let's see here. I want to take a look at the protein sequence first. So I'm going to open that with Notepad++. Alright, file. Alright. Open. Go to my desktop, and I'm going to look for the sequence. It should be the second sequence 1. I should rename those, but let's see where I put them. Sequence, yes, with a 1. So let's open that and make sure it is what I think it is. Yes. There we go. So what I want to look for in this sequence is what we're looking for here in this assignment is your start and stop codons. And so start and stop codons, well, they're going to start with the up here and back here. Now we're in amino acids, but this is going to tell us where at least the beginning and the end of our gene is. The problem, we can't just go and find it in an easy way because there's been splicing in there. Pieces have been cut out. But the beginning and the end, at least we can find the start and stop codon, and then we can look for splicing afterwards, but we can at least find where it begins and ends. So the way to do that is, and I'm just going to do it right here inside of our FASTA file, I'm going to take the first couple of amino acids. I'm going to put them here. I'm going to put some spaces in between them. Actually, let's do it this way. This is the easiest way. I've done this many times, and this is definitely the best way to arrange this when you're doing something like this. We're going to take those, and beneath them, okay, I'm going to put amino acids that would code for these. Now we just have to go back one step. Normally, you would, if that sequence that we downloaded had been DNA, we would have had to find the complement. But here, all we have to do is go backwards. And of course, methionine is the first one. And let's see if we can find a. Let's see if I've already downloaded the genetic code. I think I forgot to do that. So let's go look. I do not have a copy, so let's go do that quickly. I'm going to go here, and we're going to go to Google, and I'm just going to put in, oops, yeah, well, I will. We'll go to Google here. I'm just going to put in genetic code, and I'll search for it, and here we go. Not the greatest version, but it will work. Let me see here. There we go. All right. So we're going to use this, and of course methionine. Let me bring back my sequence here. M. M stands for methionine, and that's our first amino acid. So we need to go through here and find the code. Of course, it's the start codon as well. So it is AUG. Now remember, we're using T's, so it's ATG. All right. Now the other thing we need to do is a C, and that's going to be cysteine. But we should make for sure. If you don't remember your code, let's see, what is, that's the IUPAC. There is a file. So IUPAC, amino acid. There was a file on D2L, if you want to go back and find that. Amino, I can't spell. Acids. Alright, so let's go find this. AD, okay, so A is alanine. Alright, C is cysteine. So we have what? We have alanine and cysteine right here. Cysteine here and 2 alanines. So let's go back, look at our genetic code. Alright, cysteine is what? UGU and UGC. So we have some options here. This is why we did worksheet 3 or 4. Was to remember this. So I'm going to do these, but remember we're using T's because we are, so I'm going to go TGT. TGT, but there is a possibility of it being TGC. So what I'm going to do is there are several ways you could do this, but I'm going to go down here and I'm going to put ATGC as a possibility. Alright, now I'm going to go to the alanine. Now the alanine is hard in that alanine has a lot of them, if I'm not mistaken. Yes, it's 4. Alright, so it's GC, but then it can be anything. Well, actually, that's not too hard to come up with. That just means it's GC N. Alright, N meaning anything. It can be any of them. So that is my code for alanine. I don't see any other alanines. Now arginine, there are 6 codons. Here for alanine, there's only 4. Alright, so we have that, and so since there's another alanine here, it's GCN as well. Now what we do is we now have the beginning of our amino acid sequence, and then since we have RNA, all we have to do is kind of put these together like this. What are my possible sequences that I need to search for the beginning of my gene? Well, I'm going to do the first one. It's always going to be ATG, but then it's TG, that's for sure. And then it can be, one of 2 things. It can be T or C. Alright, and then it's GC, right? GC, and then it can be any of them, so that's A, C, G, and T, and then another one of those, it says GC, and then any of the 4, so that's A, C, G, T. So with that, I now can, let me do this different. I have several options. The first one, maybe I shouldn't do this as 1, I'll use this as my base. Here we go. So they're always, all of them are going to be ATG, TG, and then we'll use T, and then GC, alright, and then it's any of the 4. Let's start with A, and then GC, and then A again. Alright, so there is one possibility. Now, there would be a bunch of these if we had to go through and find all the possibilities, but notice that the first 4 are always ATGT. So let's see if we luck out and our sequence that we're looking for has an ATGT in it in about the right place. So we're looking for about 5,000. So it should be a little after that. The 5,000 mark should be about where the mRNA starts, the transcription start site. So a little bit further down, we have the gap between it when it starts copying. Then we'll have a UTR, and then you'd have a start codon. So, anywhere 0, maybe 100 base pair at the most, and then we should see something like this. So let's go see what we can find in our sequence. So I'm going to go open that other sequence. Let's see, where was it? I put it on the desktop, and it was this one. So yes, this is that long one, 8,000. And so what we're going to do here is I'm going to search, and I'm going to find all. Make sure you click at the beginning, so it'll search through the whole thing. If you're clicked in the middle, it'll start from where you click and go to the end. And so what was the sequence we needed to find? Let me go back. Let me see here. Oh, it's up here. I have it. It's this one. Alright, we need ATGTG. Alright. ATGTG. There we go. So now this one, yours may not have as many things as I'm going to go select all. You may have to do them one at a time. Depends upon your app. I'm using Notepad++, or in this case on Linux it's Notepad QQ, which is a copy of Notepad++ for Linux. If you're on a Mac or Windows and you're using it, you might also use Notepad, but just keep in mind that you need to search for this sequence, and look what I find. Okay, so it unfortunately makes it this really dull purple, but we need to find out if any of these, we need a much better color here. Let's see if I can change the color. Does it let me change the color? No. That's a shame, because I'm not sure you guys can see that. Can you see that that's purple there? I hope so. But I need to find it at essentially around 5,000, or at least on the other side. The first one after 5,000 hopefully will be the sequence I'm looking for. So how do we figure this out? Well, there are 70 characters on every line. So if I click here and I look over here, it says, where does it say? I am at the 71st character. That means at the end so there are 70 on every line. Well, I want 5,000, so here, let me pull out a calculator, show you how to do this. So about where will I need to look? What line? Well, 70. Alright, we have the one line that we have with our description, so it isn't the first line. We'll have to add a line at the end. But if I'm looking for about 5,000, we divide by 70. What character am I looking for, or how many lines do I need to go? Well, I need to go about 71, 72 lines. So we'll go to line 71 or 72, and then we'll look for the first ATGT here and see if we can do anything. So here we are. So where is line 72? Line 72, see, I have this labeled here, is right around here. So we'll say that starting here, now we need to search for our sequence, which is ATG. I've forgotten the sequence again. ATGTG. Alright. Yeah, there we go. So I'm clicking on 71, and then I'm going to do find. And so for mine, I search through here, and here it is, right here, right around, what is that? That is on line 74. Alright, and it is what? Line 74, column 41, so around 40, roughly, because you count 0, 1, 2, 3, 4, so 40. Alright, and that would mean it is, that should be our start codon. Now, how do we make for sure? Well, let's grab this little piece right here. I'm going to go to, let's go back to our other sequence. Well, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We've got 12 bases here. So let's make for sure we get at least 12. And that's 1, 2, 3, 4, 5, 6, 7, 8, 9. That's at least 12. And I'm going to copy that. And we're going to go back to our this one. And we're going to see if that sequence matches up with what we should have here. So ATG. Alright, let's do it in threes. So yes, ATG, TGT, is that good? Yep. And then GCT, will that work? GC, yeah, it's in. And GCT, yes. That's enough to convince me that that's the start codon. It's in the right spot, and the first 4 codons are correct. Let's do one more, CGG. Alright, and see if that one is correct. So let's go look at our code. There we go. So CGG, what is CGG? We look on our code here, CGG, that's arginine. Alright, now let's go back and see if on our protein, let's go find our protein again. Is that what it is? R, yes. So MCAAR and R is arginine. Yes, absolutely. That to me tells me that there is our start codon. Oops. Alright, so I need to click here. It's right there. Now what can you do with this? Well, it's hard. You can then take this and convert it to something other than a text file, and then it'll let you change the color or something like that. And it'll let you count out the number of lines. You should count out how many there are, or actually I am fine, to tell you the truth, if you take this and then alter it and show me that that's your start codon. Start is green, I like that. Change it to green, how about that? Something like that. But somehow tell me that you think that's the start codon, so I'm giving this one to you. In other words, I am telling you that that's the start codon, and so you should all get that one right. Now let's see here. Where can we, what can we do to it? Well, I can edit it. And I can do things like, I can't change much because it's a text file, but I could, I can make it small letters, some other things. But if you do cut and paste this into, say, a Word document or a RTF or something like that, you will be able to change the color, and I will accept that. Otherwise, you can go find the number, wherever this is in the sequence, and give me the number. I would like to have both. As long as you indicate that you know that that's the start codon, that's all I'm looking for in this part of the assignment. Make sure you know that. Now, so what else do you need to do on your own? I've given you this, so what else do you need to do? Well, you need to find the stop codon. Alright, and that, or the stop codon will be the one right after this. So what do? You do this in reverse. You take a few of these, reverse translate it like I did here, and then go search. And where is it going to be? Well, it's going to be after the start codon. Alright, now it's not necessarily going to be close at all in the sense that you got the whole gene, but you also have the introns, and the introns may be longer than the coding sequences. So realize that you may be several thousand base pair after this. After all, we're at 5,000 and this goes all the way to 8,000. So you might have to go, I'm not going to give you any hints on that. I do know where it's at, but you're going to basically go and find what? Find that. And now you also know what the stop codon is. The stop codon, there are three options, and that would go on at the end here for this sequence. So you will need to go and find the stop codon. And that will be the next part of your assignment, is finding the stop codon. And then we can go back and find the splice sites. So work on this. If you have any problems, feel free to Zoom. But I've shown you how to find the start. You'll just have to go here to, say, PSCA, convert it, plus add a stop codon, and then look for that sequence somewhere in the code, and that will help you. And then once you find the start and stop, we'll have a video on how to find the splice sites. Alright, and that's it for this video.